about Ohm's law. Okay? And when we view Ohm's law basically states that voltage equals current times resistance. So what does that really mean? Remember, if we back it up, we had these current, which was the amps. Those are your electrons. And then you had resistance, because we don't want too many of them to flow through a wire. And then we have voltage. Things are going to push those electrons through the wire. All three of these make up the formula with Ohm's law. Voltage equals current times resistance. So in order to calculate this, basically your amps, those electrons that flow through it, times all the things that are going to prevent them from flowing too much, because you don't want too many of them to flow through, equals the amount of voltage that's needed or can flow through a particular wire. Okay? So what we're going to do is we're going to basically practice it. When you look at the formula, voltage is on top, I, which is your amps, and R, which is your resistance or ohms, are on the bottom. Side by side, you multiply those. All right, so here we have some Ohm's law practice. First of all, what we have is a wire. Oh, let me back it up, because you have a chart that's on your graphical organizer. So what I would like for you to do is to pause at this point, work on those problems, try it, and then raise your hand, and then Miss McClung will go around and check those answers. Okay, now we're going to continue with Ohm's law practice. Now that you've put your answers in the chart, hopefully you've got them checked off. So now we're going to continue. So with Ohm's law practice, what we have right here we have a wire that's carrying 25 amps of current, and it encounters a resistance of 10 ohms. How much voltage is applied? So when I look at this, and I'm going to draw, let me see if I can get my pen color here, red. And I'm going to draw the triangle here, okay? And remember, voltage is going to go up top. So we got 25 amps. 25 is right here. It is my amps. It's I. And then we have 10 ohms. That 10 goes right here. They are side by side. That means I'm going to multiply. That means up here I'm going to solve for the voltage. So when you multiply that, you get 250 volts. And I know I'm struggling trying to write this. It's hard with your pen. So that's 250 volts. Okay? Now let's look at the second problem. We got 300 volt battery, and it's attached to a wire of 100 amps. Okay, we want to know the resistance again. So what I'm going to do is I'm going to draw my triangle, and we're going to fill in the information. So I know I got 100 amps, so remember the 100 goes right here. But I also have up here 300 volts, so that 300 is going to be seen up top. Okay, one's on top of the other, so my operation is I'm going to divide. So 300 divided by 100 would be 3. And on there, I'm going to write the little symbol for ohms. Okay? All right, now we're going to transition to power. This is like the power that's in your home, power's in your lights, power in your lamp. Basically anything you plug in, you want to determine how much electrical power is in there. It's going to have the same power unit that we learned previously with work and power. Is going to still be a watts. So our formula for this one is our electrical power is the current that pushed through a wire, the amps times your voltage, which is that push. So the electrons times the pushing of them gives me how much power that an instrument or item has. So let's practice this, okay? So first of all, let me go back. First of all, let me get my pen, and let's use green for this one. All right. So what I have right here, I want to know how much power is there when I have a 20 amp current that flows or has a voltage of 10 volts. Okay? So over here, I and V are on the bottom. So I'm going to put a 20 here. And I'm going to put a 10 here. So when I calculate these two, 20 times 10, I get 200. Now, it's asking for power. So my unit for power is a W. It's a watts. Okay. So let's look at number 2. We got a 90-watt light bulb. And it has a current of 45 amps. And we want to know the voltage. So now I'm given power. And remember, my power is on top. So I'm going to put that 90 right up here. So remember, if it's up top, the operation we're going to perform is we're going to divide. The current is 45 down here. And we're going to solve for voltage, which is right there. So 90 divided by 45 is, on that one, should be 2. So when you divide 90 by 45, you should get 2. And on there, it's volts. Okay? Now, are there any questions at this time? All right. If not, then what I would like for you to do is to pause, and I want you to work on your worksheet at this time. Thank you.